Hello everyone. In this video I am going to explain remaining type of sets. Subset. Every element of a set A is an element of set B, then A is said to be subset of B. Subset. Subset is nothing but A is subset of B. We will represent like this: A is subset of B. Subset symbol is elongated, see, with the line down. Okay, every element of A is an element of B, then A is subset of B. That means, suppose you will take A is equal to 1, 2, 3, the set 1, 2, 3, and the B is equal to the set 1, 2, 3, 4, 5. Every element of A 1, 2, 3 is there in B set 1, 2, 3. So A is subset of B, we will call here. A is subset of B. And here, suppose the set of triangles and quadrilaterals are there, is a subset of set of polygons. Set of triangles and quadrilaterals are subsets of set of polygons. If we'll take the natural numbers, whole numbers, natural number is subset of whole numbers. Whole numbers is subset of integers. Like that, you know that integers are subset of rational numbers, and rational numbers and irrational numbers together called as real numbers. Those are all subsets. So that is a subset means. What is meant by subset? Next, superset. Superset. What is a superset? In the above case, A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5. So B is the superset of A. B contains A, or A is contained in B. B contains A, or A is contained in B. Then B must have the more elements, then B is superset of A. As naturally we know that sub means subordinate, like that. English meaning also like that only. Sub means less. Super means higher authorities, superiors, like that. Super. The same in mathematics also will indicate like that. Subset means it must be less than or equal to another set, and superset is the set which contains more elements than the given set, than the first set, like that. Universal set is superset of all related given sets. So superset is a universal set means that also I will discuss. Universal set means the set of all elements which contains all elements of the given set is called as universal set. A set which contains all elements in the given set, that is called as universal set. Universal set. Universal set is a set which contains all elements of the given set. Suppose I am taking natural numbers, whole numbers, integers and rational numbers, and irrational numbers separately. All these are comes under real number set. We will take real numbers. Okay. So real numbers becomes the universal set in this case. Suppose we will consider only natural numbers, whole numbers, integers and rational numbers. In that case, rational numbers becomes the universal set. In that case, rational numbers becomes the universal set. Okay, that is the example of universal set. Suppose real number set is a universal set of natural numbers, whole numbers, integers, rationals and irrationals. Like that only. One more example is a plane is a universal set, and with the set of all points in the plane. Okay, the plane is a universal set for the set of all points or all lines which belongs to the given plane. Okay, this is about the universal set. Next, coming to proper subset. Proper subset. If A is subset of B and A is not equal to B. Proper subset. If A is subset of B and A is not equal to B. Already equality we discussed. Number of elements are same and elements are also equal. Then we'll say that A equal to B will write. Here A is not equal to B and A is subset of B. Then A is called the proper subset of. A is called the proper subset of B. Suppose A is equal to the set of elements 1, 2, and B is equal to the set of 1, 2, and at least one of the element must be more than that A, because A is not equal to B condition also should be satisfied. That's why A is a proper subset of B in this case. In this example, A is proper subset of B. Okay. Next, power set. power set. Suppose A contains the set 1, 2. What are its subsets? So subsets of A are null set, because empty set is set of subset of every set, and the set containing 1, the set which contains 2, and A is subset of itself. Every set is subset of itself. So these are the subsets of A. 4 subsets are there for the set which contains 2 elements. So if n of A is equal to 2, then number of subsets is 2 to the power of n. That is 2 square is nothing but 4. 2 square is nothing but 4. Then coming to the power set, the set of all subsets is called as power set. The set of all subsets is called as power set. So power set of A can be indicated by like this P of A. And what are the elements in P of A? Null set. All sets are behaving as elements in the power set. The set 1, the set 2 and A are the elements of power set. Okay. So this is the power set. This is the power set. P of A is equal to the set 5, the set 1, the set 2 and A. So number of elements in the power set is also 2 to the power of n. Number of elements in the power set is also 2 to the power of n. Then this is about this. Then after listening all these concepts, what we can conclude? What we can conclude? So we can conclude that null set is subset of every set. Null set is subset of every set, and every set is subset of itself. Every set is subset of itself. Next, if number of elements in set A is n, then number of subsets is equal to 2 to the power of n. Number of subsets is equal to the power of n. Number of proper subsets is 2 to the power of n minus 1. Number of proper subsets is 2 to the power of n minus 1. Number of elements in the power set is 2 to the power of n. And number of non-empty subsets is equal to 2 to the power of n minus 1 you will get. So these are the concepts of universal set and subsets and remaining. Next, coming to the exercise 2.3 and 2.4. Exercise 2.3, which of the following sets are equal sets? So x such that A is equal to x such that x is a letter in the word follow. Next, B is equal to the set x such that x which is a letter in the word flow. This is A, this is B. And C is the set of x such that x is a letter in the word wolf. C is equal to the set of in these three cases, what are the letters in the set? Repetition of elements are not allowed. So what you will get? F one time, O one time, L one time and W for set A. And that is equal to set B also, and that is equal to set C also. So all are equal sets. All are equal sets. Set A, B, C are equal sets. Next, in the second question, we had to say that whether they are equal sets or equivalent sets. Equal sets means number of elements are equal and number of elements are also same. Number of elements are same and elements are also same. Equivalent means only cardinal number is same. Next, so A is equal to B or not, you have to check and you have to give the reasons. And fourth one also. Coming to the fifth question. So suppose the second bit, fifth question, second bit I will consider. So C is equal to the set X, Y, Z. C is equal to the set X, Y, Z. What he asked? List all the subsets of the following sets. List all the subsets of the following sets. Already explained in the example. One more sum I will explain here. So what is number of subsets of C? Number of subsets, before going to the number of subsets, you have to write the cardinal number. What is the cardinal number of C? N of C is equal to 3. N of C is equal to 3. Then number of subsets is equal to number of subsets is equal to 2 to the power of n. So 2 to the power of 3 is nothing but 8 subsets you will get. 8 subsets you will get. So what are the all those subsets of C are? All subsets of C are, already we discussed it that phi is a subset of every set, so null set is a subset. Next, each element, the set formed by each element of the set C. So each element means X, the set X, the set Y, and the set Z, and also in combination of elements of the set C. So in combination means XY is one combination, and next XZ is the another combination, and next YZ is the another combination, and next C. The given set is C. And we know that every set is subset of itself. That's why C is also subset of itself. 1, 2, 3, 4, 5, 6, 7, 8 subsets are there. So this is the answer for that question. Next, coming to the do this, you have to identify that whether the given sets are empty or not. You have to justify asked. So set of integers which lie between 2 and 3. In between 2 and 3, there is no integer. There is no integer between 2 and 3. Therefore, it is a null set, empty set. Next, second bit is set of rational numbers are there smaller than 1. Natural numbers less than 1. Natural numbers less than 1 is also null set. Already we discussed. So, it is also a null set. Next, third one is set of odd numbers that leaves the remainder 0 when divided by 2. Odd numbers leaves the remainder 1 when divided by 2, but here given remainder 0, that's why it is a null set. Like that only you have to identify the finite set or infinite sets. So if you understand the concepts of finite, infinite, so easily you can understand that. So A is x such that x belongs to n and x is less than 100. So x is less than 100 means it's a finite. Next, second bit x such that x belongs to n and x is less than or equal to 5 is also a finite. Next, c is equal to 1 square, 2 square, 3 square and so on is given. So there is no condition, no last number in that set. So it is infinite set. D is a finite set. The set 1, 2, 3, 4 contains is a finite set. So like that we can do. And next, try this first bit. Try this first bit. Which of the following sets are empty? Justify your answer. So A is equal to the set x such that x square is equal to 4 and 3x is equal to 9 they have given. So x square is equal to 4 means x is equal to root 4 it becomes, that is equal to plus or minus 2. X can take either 2 or minus 2. And 3x is equal to 9 means x will take the number 9 by 3 is nothing but 3. So x is a number which will take 3. So that means here you are getting plus or minus 2 or here you are getting plus 3. But both the conditions are not satisfied by the any of the number. So it is an empty set. It is an empty set. So this is the reason you have to give. Okay. Next. The set of all triangles having the sum of their three angles is less than 180. So sum of three angles is 180, then only we will tell that if it is triangle, or if it is a triangle then sum of three angles is 180 degrees. But here he has given that less than 180 degrees, so it is a null set. And next, think and discuss of page number 48. Think and discuss of page number 48. What is that? An empty set is a finite set. Is this statement is true or false? Why? An empty set is a finite. Is a finite set. Is a finite set. You have to justify. Empty set means indicated by the indicated by the Scandinavian letter phi. And what is the cardinality of null set? You know that cardinality of null set is 0. So it contains no element in it. So n of phi is equal to 0. So we can say that it is a finite set. For example, we will take the set A is equal to the elements 1, 2 and the set B is equal to elements 5, 6. So what is A intersection B? Intersection means any common element is there? No common element. 1, 2, 5, 6. So it is a null set. As we know that A and B are finite sets, A and B are finite sets, their intersection is also finite. Their intersection is also finite. Their intersection is also finite set. So that's why we can conclude that an empty set is a finite set. An empty set is a finite set. An empty set is a finite set. Okay, we can conclude. Have a nice day.